G'day and welcome to the Northbourne Repair Cafe YouTube channel. A bit of a fun fix today. Been working on a little Game Boy, one from 1989. Just found out of the e-waste bin, basically dead, no life at all. And so hopefully you can follow the repair diagnosis that we do and see how far we get. I hope you enjoy it. So today I'm going to try and diagnose and repair a Nintendo Game Boy. As you can see, not in great condition, missing the transfer sticker around the outside of the screen, and quite grubby condition. Got the game Robocop in it, so hopefully I've got something to test it with if I actually do get it working. And so let's see how we go. I've thrown some batteries in it very quickly and shown that there's no life in it at this stage, so I've got no idea where to start. So let's give it a go and see what happens. The first thing I'll try to do is I'll stick some batteries in there and see how the battery compartment and the power supply section is working. You may be able to see in there's a reasonable amount of corrosion there. It doesn't look so bad on the surface. I wonder if you can see in there. This side's probably a little bit easier to see the corrosion, but I'll stick some batteries in, which I've just tested to make sure they've got about 1.3 volts at least. These are not new batteries, but we'll see what we can do. Should be able to get some life out of it. I'm really just checking for continuity. I think I just put, oh, that's in the correct way. To see whether it's just a simple power supply issue. I'm just giving it a bit of a rub backwards and forwards to try and improve the contact. First thing I'll try and do is see whether I can trace the voltage through from one end of the battery to the other, which will help work out whether these contacts and springs that travel through here are all working. The battery is a 4 lots of 1.5, which adds up to about 6 volts. So what we've got to do is actually hope we get 6 volts from one end of this battery trail chain to the other. So I've got the negative of the first battery, and just tracing through the battery connections, you can see logically it's supposed to go like that. So this end of this battery should be the positive at 6 volts relative to the start of the battery train here, which is what I'm going to use my black probe on. So what we should have there is about 6 volts, or maybe a bit less because my battery's alright. Well, that's actually looking alright, isn't it? That looks like we've got continuity all the way through there. That's a good start. Alright, and I hope that stays there. I'll just do a double check to make sure we're getting not the edge of the battery but the actual terminal itself. And yeah, it looks a little bit, maybe a little bit flaky there. I'd suggest we've got close to full battery, but we're getting through. But every now and then, yeah, we'll go with that for the moment. I think that's okay. I'll just put the battery cover back on. And we'll turn it over, and let's hope they don't lose contact, and switch it on. Make sure this one's got a contrast on it here, so we'll make sure it's fully up. Doesn't look like anything's happening in there. Alright. No life on that screen. Okay. Turn it back off again, turn it back on again, see if there's a dodgy switch maybe. No, nothing. So I noticed this Game Boy's got an external supply, voltage supply option as well. I'll just see if I can see the 6 volts, or roughly 6 volts coming through to this point as well. And yep, it's looking good. I've got these probes the wrong way around, but anyway, that's showing the same battery voltage that I was measuring in the battery compartment, so that's a good start too. So it means that the internal connections, at least for that part of the circuit, are intact. Alright, I think, oh, guess what? I think there's a light there as well. Not sure if that's coming up. Oh, there we go. Okay, and I think I heard a click on a speaker. So there we go. We've got some logic there as well, perhaps, or at least some power getting through to that side of the circuit. Okay, now what about, I'll try that contrast again now just to see if we get anything. No, I'm not getting anything on the contrast there. Oop, got some speaker action happening there. Not sure what that is, but I think it's time to open it up. I'll turn that back off again. Let's have a look inside, see if there's anything obvious. I thought there might be some sound that came out if that Game Boy started up. To be honest, I don't even know if these got, I assume they've got a speaker in here. It's got a headphone jack as well. And we could hear some sound, so it's coming out of the speaker. I assume the game would just start playing if it was actually working internally. So I'll just turn that back on again. Looks like that light did not come on this time. Interesting. Interesting. I wonder if we still do have a bit of a loose sort of power supply arrangement here. Either way, I think it might be time to open up. Just to give you a closer look at some of the battery connections in there. Something that definitely needs to be cleaned up there. You can see that corrosion there around that spring. Now these springs are actually just clamped on to that base material, and the corrosion can cause high resistance between that plate and the springs. So I think if I can, I'll take these out and give them a real good clean and make sure I've got a good contact. May even try to see if I can do a bit of solder on there just to give a good connection, but either case I'll take it out, clean them and make sure we've got a good connection there later on. But the other thing to notice is those screws there are not the normal phillips head or sort of slot head screw heads. They're a 3-lobed screw head, not at all common. I saw this a few weeks ago and actually ended up ordering for a couple of dollars the right screw head for this, and whoops, a little bit out of focus there, but this is the unit I've got. Only costs a few dollars, but it looks like it fits in to the heads very well, so I'll just undo this and let's have a look inside. So I'll be back shortly. So let's carefully remove the cover. Not sure how it's connected. Obviously, yes, I see. So the screen is connected there. I'll see if I can loosen that screen ribbon cable without doing any damage. Looks like it just slides out. And zoom out a little bit so you can see what we got here. Oops. There, the two parts showing a bit of corrosion here actually. Not sure where that plate's supposed to be lifted up. There's corrosion along there. Not seeing too much obvious other error issues on the surface here, but yeah, there's definitely a bit of corrosion in and around it. So we'll have a closer look at this board and see whether actually, now what we do have right down in this corner, some great little bugs. I'll just zoom in so you can have a look at them. Why not? Oops, make sure I get that so you can see. Now, there you go, little millipede there, and looks like a little bit of one there. Probably not the best things to have in your electronics. So I think the next thing to do might be to remove this board and have a look on the other side as well. Have a real close look at it, and maybe under the microscope to see if there's any traces that are obviously broken or corroded, and repair them if we need to. So just give me a few more minutes and I'll take that board out. Well, so there you go. It's quite a bit of debris, possibly where that creature was living, and worth giving this a bit of a clean up because of those contacts there do need a bit of a clean up. But what is interesting to me is, and maybe related to our problem, is if you look at the two sides here. The power coming from the battery, which is in this section here, looks to be transferred through to this other board. are these contacts here. 1, 2, and 3. And it is quite possible, looking at the corrosion on this, that these contacts are not as healthy perhaps as they should be. So that's given me something to aim at anyway. I'll have a good look at this, and I'll clean up. You can see this particular part of the unit is not looking all that neat either, so I'll give this all a bit of a clean scrub, and before we put that back together. I won't get too carried away and try to get back to original colour, but I'll try and at least get rid of all the grime and make sure the contacts are good. So just checking around this board under the bench microscope, you can see some signs of corrosion. There's this transistor here. I'll do my best to help you see that. Now the interesting, the copper legs looks like the plastic insulation has come off that. So I do know in some audio transistors this can be a problem with corrosion tracking up from the legs up into the inside of the transistor. So I'll keep that on my suspect list for the moment, but it actually doesn't look too bad. So I'll just keep going around. Sorry, I'll try and get you back in focus a little bit here. The lighting's not brilliant on this, but let's keep going around. Mostly it doesn't look too bad, and these contacts don't look too bad. I'll give them a bit of a rub before we use them. However, this resistor here looks terrible. Let's see if I can zoom you in as close as I can. No, it looks like it's a different setup, but basically that resistor is badly corroded and cracking. Cracking on that side, and there's sort of stuff coming off it on this side. It is stuffed. There you go. Alright, so that one will get replaced. I better not take too much off. I want to get the colour codes off it so I can get the right resistor in there. Now, if I quickly go to the other side, there's not too many components on there, but just checking through the tracks, it doesn't look too bad. Once again, as I said, I'll clean up these contacts for the controls. But other than that, I think we can live with that. No obvious dry joints, but probably not expecting too many of those, given that's not a high power device. It wouldn't actually heat up and cause the sort of cracking you often get in other boards. So might check those speaker terminals. Yeah, they look alright, I think. Once again, we can live with that. And the speaker's just full of crap, but yeah, I can give that a bit of a blow probably to clean that out. Careful blow. Alright, and last thing I'll do is just have a quick look at this ribbon cable. Make sure there's no obvious tears. I have to be pretty gentle with these ones for the display. But it looks okay, I think. I'll probably clean up those contacts, but before I reinsert it. But other than that, it doesn't look too bad. I think we can. I don't suspect that's damaged. So, all right. I think let's continue our checking. So I had a close look at the board again, and noticed in the area where that resistor was corroded, this diode just beside that device which is connected to one end of that resistor. Looks like it's connected to the board, but there's this what looks like a blowhole, surprisingly, through there, as if we've had some fault in this board. So I've decided what I'll do is I will connect the board and I'll measure the voltages around this area and just see where we're at. Okay, so the batteries are back in the device, and I've connected it. I haven't actually turned the power on now. You can see that LED light is not on. Oops. Okay, now that's on, red light down there. So I'll just flip this over and show you the measurements around that LED, which is near that diode that I was mentioning. So I'll just pick up the negative end of the battery trail here, and you can see coming into this resistor is 5.6 volts or 5.5 volts. This is this dodgy resistor, but surprisingly I've measured it, it's just on 1K, seems to be actually working even though it looks dodgy. So we've got 5.2 on the other side of that, and which is basically the same as the base because it's connected to the base of that the diode, or sorry, one end of that diode. If you look at the other end, 2.68. So I managed to find a schematic for the Game Boy, and I've just got that on the screen here now. So the components that we'll look at first are just the basic power supply components. So the way I read this is this section here is the combination of the battery or the external supply coming in via the switch, the power switch, and in this case connecting up across here and then down through that diode, that resistor and diode I mentioned earlier, through to the earth here. So a very simple part of the circuit. So just because that bit is working doesn't really mean the rest of the device is working. So I guess that's given us some explanation as to why that LED light is working. All it really needs is that power supply to be working for that light to come on. What's more interesting is, I guess, the area through the DC converter board, which is obviously indicated here. There's a transformer, and it looks like it's a switched mode device here, which supplies the plus 5 volts and the minus 19 volts as the output for the rest of the circuit. We can ignore the bottom parts of this screen here because they're not really relevant. They're obviously for different parts. This one's a battery charger unit and this one's an AC adapter unit. But the main part is the top half of this board here. Oh, sorry, this diagram here. Alright, so we'll do some measurements. What I'm going to do is I'm going to solder on a couple of wires so I can get this 6 volt supply from my benchtop power supply. That'll give me an indication about what sort of current's being drawn, and then give me a more reliable supply than the batteries, which as I showed earlier, the battery termination corrosion is a little bit fluky, so I'd like to avoid that as best I can to try and debug the rest of this circuit. So I'll show you in a minute what I've arranged. So they say you learn something new every day. Well, today's lesson is replace the batteries in your wireless audio recording system. Otherwise, you get no audio feed. So here's an overdub of the audio for this particular clip. What I'm showing you in this clip is where I've joined the benchtop power supply to where the battery would normally supply the boards. And also the third connection is where I've actually hardwired and earthed to the display board to one of those spring earth clips or connections that make contact when the unit is fully closed, just to make sure I've got a very good earth from that part of the board as well, or that part of the unit as well. So now I'll just demonstrate that we're getting the right sort of voltage in from the power supply. I'll check initially at the main connection, but then also show you how it traces through that part of the circuit that supplies the LED power indicator. So that's one side of the resistor that was looking a bit dodgy in the previous clip. Then onto the base of the 3.5 volt Zener diode. The other side of that, 2.8, which is connected directly to the base of the LED light. So we're getting 3.9 volts all the way through the LED, which is giving us that indicator on the front. So what we'll do now is we'll look for the voltages on the pins on that ribbon cable that connect the logic board to the display board. And pin 3 should be minus 19 volts. And that's certainly missing. And if we go 3, 4, 5, 6, 7, 8, 9, 10, 11, that should be plus 5 volts. And that's missing also. Now if I go back here to just double check, pin 2 should be the 6 volts, and it is. Okay, so what that appears to indicate is that in this switched supply, the DC converter board, that maybe there's a problem with the two lines coming out of there on pin 11 and pin 3. That should be the plus 5 and the minus 19. So that's where I'll look in the next stage. So I've removed the main board from the Game Boy casing now, just to try and trace the DC converter board supply. And that's this small board here, the DC converter, and and this is the one that should be supplying the minus 19 and the plus 5 volt. So coming into this board is the 6 volts, as we would hope, but looking at a bit of corrosion on this board, it looks like potentially the line that goes along the edge of this board is corroded. It takes the 6 volt input right through to the other end of the board, and it is not getting through. So that's a good place for us to start. So what I'm going to do is put a small jumper wire to reinstate that supply, and I'll have a good look at this board under the microscope just to see if there's any other damage in that area that needs to be repaired. So I've managed to scrape away a little bit of that track that was on that DC converter board, and you can see quite clearly that the corrosion is has eaten away at that track. So there's nice shiny copper here, a little bit dull there, but as you get to here, we've basically got a fully corroded track all the way through here. Then get a bit more bright copper This end of the board's okay, a little bit more corrosion towards the other end. Not quite as bad, but still not good. And at the very end a little bit more as well that I've scraped away, but as I suggested, I think I'll just run a connecting wire from the VCC input here, this pin, right through to the other side of that board. At the other end, oops, trying to get you in focus here, to the other end down here. Alright, so give me a few minutes and I'll sort that out. Okay, so I've run that bodge wire from the VCC down to the other end of the board. Not pretty, but it's connected. It's not shorting anything that I can see. And so I think we'll try and power it up again. Okay, so let's test the voltages. I've got the bench top power supply providing 6 volts into this line here. Well, into the battery, which gives us 6 volts at this section. If I go now to those other 2 supply lines that should be coming out of this converter board, this one is supposed to be at minus 19, and yep, minus 20.94. That's quite fine from what I've read. And this one here at plus 5.1 is fine as well. So I would suggest that we have solved the problem we had in this particular part of the board. So let's reassemble this bit, and well, let's not reassemble, let's have a look at the rest of the board and see if we can get some life out of it. So we can check on the ribbon cable now to make sure the supply is being sent to the display board. And the first place to check is where the minus 19 volts is supposed to be. And yep, there we go, yeah, our minus 20.1, or 21 I should say. And then the next one was the plus 5 volt, which is there as well. So good news is all of the required supplies are getting through to the display board. So that's good news. Well, made some progress, cleaned up a little bit of the board, just checked where there was some corrosion on the main board and flushed it away. And still no success on the screen, but I'll show you in a minute. Well, let you listen to the fact that it seems to be working, except for the screen itself. So I'll turn it on and we'll see how we go. So that's a successful sound. Now let's see if I can select, there we go. I'll turn it off and we'll try again. You hear the ping when it first starts. There she goes. And then looks like if I just do select, oh, no, I didn't have to push anything. So obviously there could be more things wrong than just the screen, but I won't be able to tell until I can replace the screen if I choose to do that. Anyway, I think I'll finish this diagnosis now, and I'll do a little bit more research to see what the options are for testing the screen, and if I feel like I might try and find a replacement screen as well. Okay, enough for now. So there you have it. We didn't quite get this one fixed, but we got a long way through the diagnosis, and it looks quite likely that the screen itself is damaged, or perhaps the connections leading to it. A little bit more research to be done there. But what we did find is the board has got quite a bit of corrosion in it, and actually eaten away at one of the tracks on the DC converter board, the small board in there that supplies the -19 and +5 volt, which is obviously essential for the function of the rest of the unit. We did manage to get it to a stage where we could prove that it's operating. We had the sound coming through, and we were able to get it to chime when we turned it on. And so as far as we can tell, it's working okay. Obviously we can't see what's on the screen, so we can't tell for sure that the buttons are working yet, but it's off to a good start. Anyway, I hope you enjoyed the journey with us today, and you never know, you might see us have another go at this later on in the year, if we can find some spare parts or a bit more information about how to repair them. Hope you liked it. If you did, please give it a thumbs up, and don't forget to subscribe to our channel if you want to be alerted to any new videos that come up. And otherwise, come back again and see us soon.